So you want to know about how to compare different diagnostic tests? Well then, you better learn how to calculate likelihood ratios. Likelihood ratios play an important role in helping you figure out whether a given diagnostic test will be informative in a given scenario. Let's use a scenario that you might be familiar with. You have a carton of questionable eggs that's been sitting in the fridge for a while, and you want to know whether the eggs are still good for hard boiling. You decide that if a test tells you that there is an 80% chance that the eggs are rotten, you'll throw them out. We call that the treatment threshold. If there's only a 10% chance of rottenness, you'll feel comfortable cooking and eating the eggs. This is the test threshold. Ideally, you want a single diagnostic test whereby a positive result puts you in this range of probability, and a negative result puts you in this range of probability, for the pre-test probability you're working with. Otherwise, you may need to perform further tests. According to a recent study in NEJM, the prevalence of rottenness among eggs on their labeled expiry date is 33%, so let's make that our pre-test probability. As for our diagnostic test, let's use the float test as an example. Okay, now let's step back to see what we have so far. We're pretty much set to go. However, it's important to note that this formula needs to be applied twice, since the float test can yield two results. We'll need to calculate both likelihood ratios to get to our end goal. A likelihood ratio is the relative likelihood that a test will give a certain result in a patient with a disease or an egg that is rotten, versus giving this same result in a patient without the disease. In terms of our scenario, the float test has a binary result. So LR positive equals sensitivity over 1 minus specificity. Conversely, LR negative equals 1 minus sensitivity over specificity. Suppose that the sensitivity and specificity of the float test are 96% and 84% respectively. An LR of 1 means that the test will not contribute any new information, since the post-test odds will equal the pre-test odds. For the ideal diagnostic test, the LR positive should be much greater than 1, and the LR negative should be much less than 1. Now, the last thing we are missing is the conversion from probability to odds. It's not too hard to run this calculation manually, but since we have the internet, we can just use an online nomogram. Just put in the pre-test probability and the LR for each test result, and voila! It spits out the post-test probability for you. As it turns out, the float test is great if you get a negative result, since you are now certain enough of the eggs' freshness to eat them. On the other hand, if the eggs float, you're not so sure that the eggs are rotten that you would throw them out without doing further tests that are potentially more invasive. For example, you could crack one egg open, but then hard-boiling it would no longer be an option. One final note is that LRs can also be calculated for tests that yield scaled results. This allows you to compare different levels of results along a gradient between definitely negative and definitely positive. I told a white lie earlier. The float test actually has 3 possible results. If we take this into account, we can't use sensitivity and specificity, but we can still use our original formula. When there are more than 2 results, we call this interval likelihood ratios. We hope that you enjoyed this tutorial. Remember that we are using hypothetical numbers, so do eat your eggs before the expiry date.